Hey everybody, it's Mr. Mott. What I want to do is go through solubility graphs and what they tell us about certain chemicals' solubility based on temperature. So our graph here tells us how many grams of solute can be dissolved per 100 grams of water. That's what the y-axis is telling us. Very typical that these graphs are per 100 grams of water. And then also how these solutes are affected by changes in temperature. Some solutes are very affected by changes in the temperature. Looking at KNO3 here and highlighting the solubility graph for that, around 75 degrees, we were to follow this kind of straight down here, somewhere around 75, 77 degrees, about 150 grams of KNO3 can be dissolved. However, if you cool this down to around 0 degrees, much less, let's say 15 grams can be dissolved. So we can see KNO3 is greatly affected by changes in temperature. Another substance that's very affected by a change in temperature is NH3. However, this is inversely affected with temperature. So as temperature goes up, the solubility of NH3 goes down. And NH3 is ammonia, which is a gas, very typical for gases to have an inverse relationship between solubility and temperature. Last thing we'll look at NaCl in terms of just sort of observing what do we see here. NaCl, the solubility of NaCl or table salt is not affected by temperature very much. If we were looking at 0 degrees, let's say 37 grams would be able to be dissolved. And then if we get to the boiling point of water, we'd be at around 40. So you're only looking at about 3 grams of increased solubility per 100 degree temperature change. So that really tells us in a real world application is that the oceans, the saltwater content and the salinity of our oceans is pretty much constant wherever you go in the world. That's why you can have sharks and so forth swimming in all different parts of the ocean, and they're not going to be affected by different changes in the salinity or how much salt is dissolved in the water. Okay, so just those are some sort of observational things to note about solubility curves. We can also do some different things with these solubility curves and some of the information that's here. So I'm going to get rid of some of these notes that I made here. And we're going to be looking at and concentrating on a couple different substances here. We're going to be looking at KClO3, and we're going to be looking at KCl. So here's my line for KCl, and then for KClO3, here's my line. And I happen to chose these. An interesting fact about these two is that around 95 degrees, these have about the same solubility, which is about 55 grams per 100 grams of water. So I'll just use KCl as an example. At 95 degrees, we can dissolve about 55 grams of KCl per 100 grams of water. Now, if we had a different amount of water, we could figure out the maximum amount of KCl that could be dissolved. So let's say that we had 250 grams of water. We could figure out how many grams of KCl that we could dissolve in it as a maximum, maybe to create a saturated solution. And so we can cross multiply and divide to solve for X, and we would get around 137.5 grams of KCl. And so we could figure out how many grams we would need to make a saturated solution of KCl if we had 250 grams of water. Remember that we're still at 95 degrees. Slightly different application that you could do. You could look at and say, well, if I wanted to know, for instance, if I had, let's say I had 30 grams of KCl, and I wanted to know how much water I would need to make a saturated solution, I could solve for it that way. And the left-hand side of my proportion is going to be the same, sort of my reference point. If I had 100 grams of water, I could dissolve 55 grams of KCl. Since I have less KCl I need to dissolve, I should have less water that I need. So when we cross multiply and divide here, 30 times 100 divided by 55, we get around 54.55 grams of water that you would need to make a saturated solution. And remember, both of these examples are at 95 degrees. So this is some of the ways that we can use some of the information from solubility graphs if we have a different amount of water, or for instance, if we have a different amount of solid and we want to make a saturated solution from it. All right, thanks for watching.